Hiya. So today what we'll be discussing is about algorithmic trading. So there are lots of content available online, especially in YouTube, with respect to algorithmic trading, which is free stuff. But I can only find one single video, and that's this one. But this too, again, it might be slightly difficult for the average Joe out there with the extreme coding that takes place here. So what I thought was I'll create a video which starts from the absolute basics of Python programming and algorithmic trading, and we'll start from like the whole mentality of like zero to hero concept. So like start from nothing and then go all the way to creating strategies and running these strategies after backtesting them. So the first thing we'll need is to install Anaconda. So Anaconda is this great data science platform. So we'll just go to Google and then type in Anaconda, and then you go into the Anaconda website and just click on products and individual edition, and you just can download the file and then just go through the installer. Just go for default for everything and the Anaconda will be installed. So it might take time to download and run the installation based on your internet provider and everything, but once the installation is done, you just have to click on that Anaconda navigator and the Anaconda pops up. So Anaconda basically is like this toolkit which has got lots of things in it, like Jupyter Notebook and Python and all those things, and you can actually use those to do your algorithmic trading. And this is the new, not the new, it's been for a while, and this is where people actually do their financial trading analysis. So once you go into the Anaconda navigator, I want you to install one specific thing. So I want you to go to environments and then click on this play looking button and open the terminal. And once you open the terminal, I want you to install Yfinance. So Yfinance is this it's Yahoo Finance, so it installs the Yfinance package, so you can download the data from them. So all you need to do is do pip3 install Yfinance. Just put enter, and it basically does the installation for you. So once the Yfinance is been installed, now we can do two major things. We can actually download the data. So first, let's go and install, well, not install, launch the Jupyter Notebook. So what's going to happen right now is the Jupyter Notebook gets opened in your Firefox. So you can see all the files that you have. So you can basically create anything that you want. So you can create a new folder or a new file. So what I'm going to do is I'm going to create the desktop, and then I'm going to create a new folder, and I'm going to call it, where's the new folder? I think it's yeah, this one, Untitled Folder 2. I'm going to take that, and then I'm going to create a new file. So, well, not a text file, we're going to create a new Python 3 file. So that's pretty much it on how to create a simple Jupyter Python 3 file. So I'm going to name this YouTube just to start off with. We'll call it YouTube1, YT1, and let's actually go through the first few lines of code. So let's start. So first, let's close some of the tabs here. So you see this desktop Untitled Folder 2. So never close that thing. So that should always be running, and we're going to work from here. So let's go through some basic stuff, like let's say a equals 5. So, and let's print a. Print a. What you get essentially is, and do shift and enter. So to run the code, you can have two ways. Either click on the run here, or you can do shift and enter. So when you do print a, you get 5. So print is essentially a function. So basically the definition of a function is like it does a certain kind of a job. It's like your kidneys have a function, your brain has a function. So the print function prints a. So you have lots of different functions. We'll come across many of the functions. You can also do simple calculations here. So for example, a equals 5 and b equals 6. we can do C equals A plus B, and then we can print C, and what you get is 11. So you can do the mathematical calculations here. There's also many other functions. Let's say A equals -5. Let's run this. So what you get is print C, which is equal to 1. So A is here is -5. So let's do what the absolute of A is. And I'm going to do Shift and Enter again. So now the absolute value of -5 is essentially 5. So if at any point, let's say you get some code from me or get some code from many other people, one of the things you could do is you could test whether what that function does. So in order to do that, all you have to do is press Shift, click on this function there, anywhere in the function, and then click Shift and Tab. Basically, it tells you what its job is. So in this, it says prints the value to a stream or to by default. So similarly, you can go to ABS and do Shift plus Tab, and then you get returns the absolute value of the argument. So I guess you got a gist of what a simple function is, or what kind of calculations we can perform in the Python Jupyter Notebook. So let's go to another thing, and that's called library. So library is like, imagine library as like an area where you can where lots of functions are stored, and you can use lots of functions if you add that library in your Jupyter Notebook. So a simple example would be, let's say I'm going to import Yfinance as YF. Now the advantage of this is, remember we install the Yfinance using pip3 install. So when I do this, what happens is that I can use the Yfinance library to download the data. But in order to do that, first I need to call this. I need to import this Yfinance, which we installed before, into this Jupyter Notebook, into this file. So similarly, I can do many things. I'm going to do other libraries as well. Import pandas as PD. Import numpy as NP. And import matplotlib.pyplot as plt. So each one of these has got its own functions within itself. So we're going to come across it one by one as we run through the program, run through the code. So I'm just going to run this, and what you see here is you can see essentially a star sign. So that's basically the code is being run. So finally, we've got the green signal. We've got 5 here, and you also notice here you see this white, what was it, gray? It doesn't matter really. So let's first download our first data. So let's call stocks, or let's call it Apple. So let's call Apple equals, we can use the YF, the Yfinance library, to download it. So it's pretty simple. So YF.download. So what's the ticker name for Apple? It's AAPL. So AAPL. And let's mention some dates for it. So let's call it start equals 2010 01 01. And let's also mention the end date. End date will be equal to 2019 01 01. Let's see if we can do all the way to 2021. Yes, so let's do Shift and Enter to run this. And you can see 1 of 1 is completed. So the entire data from 2010 to 2021 January is being downloaded, and it's stored in Apple. So you can see the amazing ability of the Yfinance library. So it's like free data, free end of the day daily data. So let me just run through this Apple APPLE. So you can see we've got the Apple's data starting from 12/31. That's like the last day of the just before the last day of New Year in 2010, and then from 2010 01 04. So those days between that is like the holidays and the weekends, all the way down to 2020 12/31. So similarly, you can download any data that you want by using Yfinance, by using the ticker symbol. So you can download multiple data at one time as well. So how do you do that? So before that, I need to talk about arrays. So let's go and create a simple array. So let's do 1, 2, 3, 4, or 5. So I've created a bracket here, and I've created 1, 2, 3, 5. So those are arrays, and stored it to A. So now if I just type in A, what I get is 1, 2, 3, 5. So similarly, you can create an array of tickers. So I can do tickers, could be SPY. So I can get the SPY data, and I can get the AAPL data, the Apple data, and let's do one more. Let's do Coca-Cola, so KO, and yeah, so it's now stored in ticker. Now I can use the exact same Apple this function here where I have to download and land it here, and just change the name here to stocks, and change this thing to ticker. Note that I have removed the what's that called, quotation, ticker. So ticker, start and end. So practically all the SPY, AAPL and KO from the start of 2010 to 2021 now will be stored to stocks. So let's run this. 3 of 3 is completed. Now let me just run through stocks, so you can see the amount of data we've got over the past 10 plus years. Multiple download at the same freaking time. So that's a beautiful thing about downloading data. Now let's go to another use of the function. So again, remember this download function here. Again, if I go click here and type in and press shift and tab, like I said before, you can understand what a function does. So if I expand it, you can say the start date, the end date. By default there's none, so that's what it's mentioned here, by default none, so that's why we're specifying the date. We can just go down and see the different intervals, the period, so we can change the valid interval. So by writing interval and then by changing it to weeks or month, we can get different data. So again, end date, you can see the format of it, year, month, date, date. By default is now. So all the many other ways of describing what this function does. So let's go to, again, rather than taking this a bit complicated, we'll just go through some simple functions here. So let's do stocks.head. So the head function basically takes the first few 5 columns, 5 rows. So you can see the first 5 rows. Similarly, stocks.tail will give you the last 5 data. So it's from 2020 all the way to 1231. So that's the head and the tail. We can also have the info function, which gives us all the information of the available data frame we have. So we've got the adjusted close, we've got the close, we've got the high, low, open and volume. So the volume is in int format, all the rest are in float format. So int is basically integer, float can be decimal points and all those other things. Now, how can we convert this? So we got this data stored in stocks, right? So if I call in stocks, what I get is this. So I can convert this to CSV file. So to_CSV, and I can actually call this or save this thing called stocks YouTube. So what this basically does is that it saves the stocks data to a CSV file. So if I press and enter, and basically you've got the stocks youtube.csv file saved in the same folder as the folder you opened the Python file. Now let's say you need to read it. So I can do read stocks, or we'll call it stocks itself, doesn't change anything. So once you give the same name, it kind of overwrites the previous name. So basically I can do stocks equals pd.read_csv. So this is where I'm using that pandas library, pandas pd. So we're going to read the CSV using the pandas function that reads CSV, and I'm going to call the name of it, which is just basically this one here. Just copy and paste it. I'm going to run this. So now if I run stocks, basically this is what I get. So now we've learned how to write a CSV file and also how to read a CSV file. Now let's make a few changes to this. So I'm gonna take this, and then what I'm gonna do is, you can see the whole column and rows is a bit complicated, so I'm gonna play around with it so you understand how to make future changes. So I'm gonna comma here, and then I'm going to do header equals 0,1. So what it does you will know in a bit once I run it. So let's do stocks. So as you can see, this one here, adjuster close, now there's a slight change. Now we can have the close, you see the close, close 1, close 2, close. So instead of that, close is now above, high is now above, adjuster close is here, so, and the low, open, and volume. So it's actually separated this. And then the other problem we can see is a date, NAN. So we'll come to that as well in a bit. So we need to change the index column for that. So I'm going to do the exact same thing, copy paste this, and I'm going to comma that, and index underscore call equals 0. Again, you'll understand what this job does in a bit. So suddenly you can see the date is now above that column. Before it was like NAN and above this. So now you can see it's more neat, more simple. You can do more changes now. Now you can do the thing called parse dates. So again, I'm going to do parse dates here. Dates equals, again, bracket 0. So what does parse dates do? So basically I can again do shift and tab, and then I can expand it, and there will be somewhere you can see parse dates. So bool or list of int names, or list of listed default behaviors as follows. If true, try parsing the index. So it's basically kind of forms a list of date times and represents it as an array. So regardless, I think we've got the idea of what we're trying to do. So once we've got all that information, let's say we need to know the names of the columns. So you've got lots of columns here. One of the ways you could do is stocks.columns should give you the name of all the columns here. So just close of Apple, close of SPY, and all those other information. Let's convert this multiple index. So this is like in a multi-index format to in like this. So let's convert this multi-index to one tuple. So I'm just going to give you a comment here, convert multi-index to one tuple. So do stocks.columns, copy. So in order to make that change, we have to first do stocks equals stocks.columns. I mean stocks.columns equals, sorry, stock.columns dot to underscore flat underscore index. So dot to underscore flat underscore index. So let's see what this function does again here. Converts a multi-index to an index of tuples containing the level values. So I'm going to run this, and then let's do the stock.columns again. Just copy and paste this. So what you'll now see is it's not a multi-index anymore, it's a single index. Now let's do the stocks.head again. Now you'll see it's completely changed. So let's just take stocks. It doesn't have to be stocks.index. Won't be the same as before. So you can see the adjust close Apple, adjust close KO, adjust close SPY. So it's in a different format. We've adjusted it accordingly. So let's again make another change to this. So let's do stock.columns equals pd dot multi-index dot from underscore tuples stocks dot columns. So let's see what this does. So convert list of tuples to multi-index. So now basically we're converting it back to the multi-index. So now if I run this, let's do stocks as well. you will see it's back to the same situation that we had right here. So now if I run the stocks.columns again, basically again it'll be a multi-index. So now you know how to convert to a single index and a multi-index. So these are some of the major things that you need to know about. Again, it's just to play around with the columns and the rows and things like that. We'll be doing simple backtesting here so that you can actually learn it from a simple perspective and then go to the complicated stuff later on in your future. But as of now, we are trying to understand it from a layman terms on how many of these things are done. So far you've learned how to download the data, how to download multiple data, and how to play around with the columns and play around with the column names and make the data more clean. We have also learned how to read and write the data. We have also learned how to mention the columns and the name of the columns, converted to from a multi-index to one single tuple, and from a tuple to a multi-index one as well. So let's continue our pursuit in this algorithmic trading course. So what we're going to do now is learn on how to create a describe function. So what I'm going to do is we're going to just do a describe, and it actually gives you every single thing that this data has. So it tells you the count, how much data you have, the mean, the standard deviation, the max, the 50 percentile, the 75%, the 25%, the minimum, and all those other things. Now, it can be of use for you in future when you get a certain amount of data. So now let's do something called .log function. So let's say stocks.log, and this one, and we're just going to use the close. We just want the value of close. So let's see what we get. So we've got an error. So let's see. Oh yeah, so there's no comma here. So let's run it now, and what you basically see is only the close column from this, just the close column of Apple, KO, and SPY. So 7.52, 28.5, and 111.44. So you've just got the close function, the close column located, and this column here takes every single row that's available. So similarly, we can do, instead of close, we can do the adjusted close to the high or low, but most of the time when we backtest, we generally tend to use the data for the close. So now we've got all the data for the close, so let's store this to basically close. So let's store it to something, so close, and I'm going to do the copy function. So copy function basically copies all these things and stores it to the close. So now let me run this, and then let's see what we get for close. So basically we've got the close data for Apple, Coca-Cola, and SPY from the date of 2009 to 2020, end of December. Okay, so now let's start our coding in drawing a graph. So for that, what I'm going to do is I'm going to remember we used the library matplotlib.pyplot.plt. I'm just going to bring it here just so that you understand why we're doing it. So I'm going to do a couple of things. So I'm going to paste that, and then I'm going to do percentage matplotlib inline, and then I'm going to add plt.style, so that's for the plotting style, and we're going to call it seaborn. So that's the style that we've gone. If you do shift and tab, it can tell you the style specification of the graph that we want. So that's it. So these are the things we need for drawing graphs. So I'm going to run this, and once I run this, now let's plot these three Apple, Coca-Cola, and SPY. So basically it's pretty simple. You just do close.plot. You can decide how big your graph should be. So for that, I'll use fig size equals bracket 12,8 to 15,8. So we're going to do 15,8, kind of make it look big. And we're also going to give a font size. So there'll be names there of Apple, KO, SPY. So you can choose how big you want it to be. So we can do font size equals 12. And just run this. fixed size minus, sorry, so its fixed size equals 15,8. So there you go. So we've got 3 graphs here. So Coca-Cola, SPY in the red, Coca-Cola in the green, and Apple in the blue. You can see everything has a different starting point. So Apple has got a higher starting point, Coca-Cola has a different starting point. So we can also do the legend, the plt.legend. So I'll show you what that does. So plt.legend, font size equals 12, and then we are going to do plt.show as well. So this kind of removes the matplot legend, this one here, and when we run this, basically got a very neat and clean graph of Apple, Coca-Cola, and SPY. So basically what a legend is that it places this thing on the left side. We can actually go with a shift tab and place the legend on the axis. So that much is done. So now let's normalize this value to 100, because as you can see, the starting point of everything is different. So what I'm going to do is I'm going to normalize this. So in order to normalize this, what I'm going to do is I'm going to first create the value. So close.iloc 0,0. So what we basically get is we get the first value on the first row, the first column of the close. So basically we get this one, 7.526071. So how about I do close dot, so we've got the Apple here, so we can actually call that by using AAPL. So if I do close.aapl, you get basically all the data of the column close.aapl. So now let's do the close.aapl divided by, so in order to divide, we can use the divide function. So we can use div. So I'm going to type in .div close.iloc 0,0. So it divides all these values from the starting value of 7.52. So basically we are doing this to normalize this data. So I'm going to do this, and basically we start from $1 and all the way to 17. So similarly, you can do that for everything. So you can also multiply it by 100, so it kind of smoothens out to the range of 100. So we can use the .mul function as well. So .mul multiplied by 100. So now you get in 100 value terms. Similarly, we can do this for everything. So in order to avoid doing this for everything one by one, we can actually do it in one single go. So if you do close.iloc 0, what you get is the first column of the first row of every single data. So Apple, Coca-Cola, and SPY. So all we need to do is we just take the close, and we do the same thing, but instead of giving it the name, we do divided by close.iloc 0, just like we did there, and then we will multiply it by 100. So now everything is in 100 range. You see, everything starts from 100 and goes up to a certain data. So let's store this in a norm close. So let's take this, copy this, and paste this, store this into norm close. So now let's plot the norm close. So just like we did it here, we're going to do the exact same thing here, except instead of plotting the close, we're going to plot the normal of the close. So let's see that. So now we've got a much more better looking graph. It all starts from one single point, and you can see in reality terms, Apple has performed much better as compared to Coca-Cola or the SPY. In fact, Coca-Cola was possibly the least performing one. SPY did pretty good. So this is much more better in analyzing graphs rather than just looking at the stock price from a start date and end date here. So in this graph, you basically don't understand anything, and it might kind of make you look or feel that the SPY has got a better return performance as compared to Coca-Cola or the Apple. So I hope you guys got a gist of the idea. So remember, we started off with just the 3 tickers here. We just started off with Apple, Coca-Cola, and SPY. You can create a ton of data. You can create like 10 data, or the fan companies, Facebook, Apple, Amazon, Netflix, and Google, and put it out here as well. So there are lots of options you can try out to understand what works and what doesn't work. So let's now say that you close this file and you run the file again. So what's going to happen essentially is sometimes you have to run the code from the beginning, because sometimes these header files will not be, these libraries might not be called yet. So what you could do is you could do cell and run all. So basically you see all these stars, so it starts running from the top all the way down to the bottom. So it takes a bit of time because you're going through lots of code, but eventually it goes through pretty smooth. So there you go, it's running down one by one, and yeah, we've got all the data that we did before. And also sometimes you could see the IP kernel may not be working because of some other reason or whatever. So in that case, you can just do the kernel and restart the kernel, or restart and run all the codes again. So now going back to where what we were doing before, we were focusing on the normalization of the graphs. So now let's focus on one single data. So we've got Apple data, we've got Coca-Cola, and we've got SPY. So what I'm going to do now is I'm just going to focus on the close of Apple. I'm just going to focus on the returns of Apple stock. So what I'm going to do is I'm going to create a new file, new column, not new column, new variable, AAPL equals close.aapl.copy function. So we're going to copy everything that's close of Apple. Close.apple gives you this data here. And I'm going to do toFrame. So the proper definition of toFrame will be to convert the data to a data frame. So once I run this, the close.apple.copy to frame gets stored to Apple. So if I run Apple now, we basically get is the data of all the close from the beginning till the end. Now let's say we need to calculate the increase or decrease from the previous day. So one of the things we need to do before that is to learn a function called shift. So what I'm going to do is I'm going to use this shift function and see what I get. So Apple shift. So basically the periods by default is 1. So it shifts index by a desired number of periods. So what it does is it moves this number to the bottom one, this number to the bottom one, this number to the bottom one. So it changes like one space. So if I type in periods equals 1, as you can see, the 7.52 gets changed to 0104, and the 7.64 goes to 0105. So that's the apple.shift periods one. So that's what the shift function does for you. So why is this quite important? I'll come to that in a bit. So let's create another column along with the apple. So one of the things I could do is create a new column by just doing AAPL, which is AAPL is our data frame here. And then I'm going to do, let's say, lag 1. And I'm going to do the same thing that I did here. I'm just going to copy and just going to paste that. So what's going to happen now is a new column will be created, and it'll be called lag1, and this shift one would be created onto these Apple data. So let's see what we get. I'm just going to run this AAPL. So as you can see, we've got the AAPL close data and we've got the lag1 data as well. So the reason why I want the lag1 data is I want to calculate the percentage change of the daily returns. So Apple has changed from 7.52 to 7.64, so I want to calculate the percentage change of that. So in order to do that, I need to find the difference between this one and this one. So I can use this data of lag 1 and subtract that with the data of yesterday's. So one of the things I could do is I could do AAPL dot Apple and subtract that with AAPL dot lag 1. So let's see what we get. So the subtract function will basically subtract this one with that one, and what we get essentially is the subtracted data. So let's store this to a column as well. Let's create a new column similar to this one here. So instead of lag 1, we'll call that, let's call it diff. That's like a difference. So copy paste that here and call it difference. So now if I run AAPL, basically what you get is you've got the lag 1 and you've got the difference. The difference is basically the change of the change of the prices as compared to yesterday. So now with this information, we can easily calculate the percentage change. So again, percentage change is pretty simple. We do the exact same principle. So AAPL dot Apple. But instead of subtract, we divide. So we divide this closing data with the lag 1 data. So let's do AAPL.lag1. Now that should take care of that. So there you go. So basically the percentage return was 1.01, 1.0, 0.98, and basically we've got the data of from 2010 to 2020, the percentage difference. Now let me store that to the Apple data frame. So we'll call that a new column again. Let's call it the percentage change. Cross a bracket, and I'm just going to run that, and then now I'm going to run this code, and there you go. We've got the percentage change on a daily basis. So as of now, you've learned the divided by function, you've learned the subtracted function, you've learned the shift function. So these are some of the most commonly used functions while dealing with data frames. So just with this, we can actually get this. So the reason why I just created the lag 1 and the diff was to make it more simple for you guys to understand. But actually you can contract all this code just from here. So from this information this information here, you can actually convert it all the way to the change. You can skip the lag 1 and the diff bit. So let's actually also discuss the other ways we can do this thing. So instead of using the shift method, we can actually use diff method as well. So so let's create AAPL, and I call it difference 2, and then instead of using the subtract method, I apologize for that. Instead of using the subtract method, I can use the diff function as well. So it's basically the exact same thing here. I'm just going to copy this here. I'm going to paste it. But instead of subtract, I'm going to use diff. I'm just going to run this as well at the same time. Cannot convert class int. Oh yeah, so basically it's diff dot periods 1. So yeah, that's a small change there. So you have to decide which period you want to subtract it from. So I'm going to run it now. So again, if you see the diff 2 and if you see the difference, it's exactly the same thing. We just use the methodology is quite different. So if I do the shift and tab again, first is create difference of the element, and if I go in the periods, you can by default will be 1, calculates the difference of a series of element compared with another element in the series. So here we're using the Apple close and the other data and then subtracting it, and basically we have got the difference. So now you basically understood how to use the difference function as well. Similarly, instead of using the divided by function, we can actually use percentage change. So what I'm going to do is, again, I'm going to copy this, I'm going to paste this, and I'm going to call it percentage change 2. So the difference here will be, instead of div, I'm going to use the percentage change function. So it'll be pst underscore change, and then I'm going to call the periods as well. So periods equals 1, and we will have to multiply it by 100 because it will be in a 0.00 terms. So I'm going to do mul 100. We discussed the multiplied function, and then I'm going to run this, and then let's do the AAPL. So again, percentage change. I think we must have made a small mistake somewhere. The percentage change here is slightly different from the percentage change there. So let me see where I made the mistake. I think it might be the previous percentage change where I made the problem here. So let's see the percentage change. Oh yeah, so basically the calculation of this one was quite different. So we have to subtract 1 from it because we have to calculate the percentage change. So we subtract 1 and then we multiply it by 100, and that's what our actual number will be. So now it should be correct here. So our percentage change is now the same as the percentage change calculation. It was just a small error from my part. I didn't think it properly. So basically what I did was, in order to calculate the change, percentage change, we subtract the first day, we divide the first day with the laggard day, and then we subtract 1 from it, and that multiplied by 100, and that's basically the percentage change. So I forgot the subtraction of 1 bit and multiply 100 bit. Anyways, coming back to the basic thing, you can see now if I run everything else, so put there, that one there, that one there, that one there. So basically now the change, percentage change 2 from the percentage change calculation or the manual calculation, is pretty much the same thing. So another way to, you've seen you've got like lots of columns here. So one of the things I can do is I can always delete the columns. So what I can do is we do just del, and then we call the name of it. So the data frame here is Apple. So Apple dot the column name. So let's remove the percentage change 2. So percentage change, let's remove diff2. So now let's run AAPL. So as you can see, diff2 has disappeared. Similarly, we can actually remove everything. Like let's delete off. So you can actually override these things. So once this deletion is done, then basically the data frame will be saved like this. So we can actually change the lag1 diff as well. So I'm going to do diff, and then I'm going to do lag1 as well. And I'm going to do percentage change as well. Then let me run AAPL. So basically now you've got Apple and the percentage change. So the other thing you want to do is, like, let's say I want to change the name of the column. So one of the things I could use is I could use the rename function. So what I'm going to do is I'm going to write AAPL dot rename, and I have to mention the columns. So what I'm going to do is I'm going to do columns equals percentage change to let's say daily change. Let's call it just change, and then comma in place equals true. So this basically will rename the percentage change to just change. So now if I run this code, you basically got the new column which just shows the change every day and the Apple data with it as well. So now, since we've got daily data, you can actually convert the daily data as well. So for that we use another function called resample. So let's do the resampling bit. So what I'm going to do is I'm going to take the Apple close data, so which is this one here. So apl.apple, which takes all the data from here. Then I'm going to do .resample. Then I'm going to do monthly resample. So basically you get all the data at the end of the month. So let's run this and let's see what I get. So let's do the, it's not displaying, so I think I need to do the .last function. And then basically what it does is that it gives you the last day of that specific month. So 12/31 the data is 7.52. End of January the data is 6.85, and end of February you've got the data, and that keeps on going. And you can see the frequency is month. So let's say you want to do the last business day of the month. So for that, all I have to do is I just take that one, then I copy paste it, and then I do BM, and that will give you the last business day. So you can see it's 0226 because that's the last business day. It's taken the Saturdays and Sundays out of the equation. So similarly, you can use this data, and also you can calculate the percentage change or the monthly returns on the monthly change. So just exactly the same way we did before. So we can do a percentage change, periods equals 1, periods equal 1, and then dot multiply at 100. So now we basically got the percentage change on a monthly frame. So at the end of January our returns was minus 8.5, end of February our returns was 6.5, 14, 11, and there it goes. So far we've made a huge progress in our coding skills. So these are some of the normal things that you deal with when it comes to data, changing the data, changing the column names, finding the differences, the percentage change. So hope you guys understood the major part of handling data, because majority of the time when you're coding, especially in Python, or if you're a data scientist, or most of the time you are actually making lots of changes to data and trying to fix and clean up the data as much as possible. But luckily, due to Yahoo Finance, you can make it more simple. So now, since we've reached this far, what I'm going to do is I'm just going to now calculate the mean return and standard deviation. So I've got the AAPL data here. So AAPL. So so now what I'm going to do is I'm going to delete the change just for the sake of it. Delete change to make it look more simple. There's nothing personal about this column. Just want you guys to learn in a simple way possible. So APL, now we've got the data. So now what I'm going to do is now I am going to do something called calculate the returns on a daily basis, or basically the percentage change. So what I'm going to do is I'm going to create a new variable, returns. Returns is equal to APL dot percentage underscore change. And then I'm going to drop NA. So there's no need for me to drop NA, but I'll tell you why. So if I do this and if I run RET, so you see the NAN is mentioned here. So what I could do is I could just drop NA, so it takes out every single NA variable out of it. So now you can see the NA is out. So what happened right now is that it removed that 1231 data completely. So any row which has NA data, it has removed that. So that makes the data looks more clean. So if I do rat.info now, you can see the information available 2264 non-null. So it's a very clean data what we have here. So now let's plot a histogram graph. So we did the normal line graph before. So let's plot a histogram graph. So I'm going to do is ret.plot. So I'm going to do kind equals, the way we name it is just by typing hist. So in that way, Python knows that the graph you're trying to go is the histogram graph. So similarly, the size and everything, which you did in the line graph, I'm going to do it the same principles here. So 12,8, comma, bins equals 1,100. So bins equal 100 shows how many bins you want, and then I'm going to do plt.show. You don't have to do it, it'll still come up, but still it's good coding. So there you go, we've got the histogram data. So we can see the returns 0.05 and minus 0.05. So majority of the time, the trading range happens to be in this range. So remember, I haven't multiplied by 100, but that would have been nice if I multiplied by 100. But basically, it's just 5% here and 5% positive and 5% negative. So majority of the time, it's Apple stocks go in this specific trading range. So I've done a video on my YouTube channel, I think it's called Probability Distribution. So in that, I've created a strategy just based on this information, this data that we've got here, based on the distribution and based on where the majority of the returns are taking place. This is a real reference for you guys to come up with a really good strategy. So this is how I come up with strategies. I look at different stocks and see where the majority of returns are, and based on that, I can create multiple strategies. So that's a really good video on the YouTube channel. Please check it out if you have got time. So now let's calculate the mean return. So mean returns will be, we've got RET here. So if I do RET dot mean, basically, as you can see, it's 0.001196. We need to multiply by 100, so it'll be 0.1%. Similarly, you can do the variance as well. So I'm just going to call this as daily mean return. Daily underscore mean underscore return. Copy this, paste that. Similarly, I can do the VAR as well. So VAR underscore daily equals RET dot VAR. So that'll give you the variance. And I'm just going to call this VAR underscore daily. And you've got the variance as well. So in order to calculate the standard deviation, which is basically the risk metric when we do quantitative analysis of any stock. So in order to calculate that, we need to calculate the standard deviation. So basically STD, I'm going to do the daily standard deviation. So this is where we use the library. Remember the library that we discussed at the beginning, the numpy library. So it's a really great opportunity for you to use that. So we're going to use a square root function, and not to use a square root function, I'm going to use the numpy's library. So np dot square root and then var daily. Let's do the std underscore daily. So there you go. So we've got the standard deviation as well. So obviously you need to multiply it by the specific return. So yeah, another way which you can do is, rather than calculating it from the VAR perspective, is just do the RET dot standard deviation function. So if you do just do RET dot standard deviation, you still should get the exact same thing. So you've got the exact same thing here. So it's 0.017841. So that's the standard deviation. Now let's calculate the annual mean return. So the annual mean return, mean return will basically be the return dot mean, which we calculated here. So daily mean return into 252. So that's the 252 amount of working days that we have. Strict 252. Let's call this. Yeah, so we're basically getting a return of 30%, so 0.30. So let's do the annual VAR return. So again, annual VAR return will be similar to this one. So we'll have the annual VAR return there. So there you go, that's the annual VAR return. We can also do the annual standard return as well. I'm just going to make this quite fast because it's pretty much the same principles. So of course np dot square root of the, instead of this one, it will be annual VAR return. We don't need to multiply by 252 because we already multiplied the VAR return here. So there you go. So we've got the annual standard deviation return as well. Similar to that, we can actually do the std function instead of everything else. So all we have to do is we just have to do ret dot standard deviation and multiply it with np dot square root. Sorry, np dot square root p. $252, and I am pretty sure we should get the exact same thing. So you can see again the annual standard deviation return calculated from variance is exactly the same as using the standard deviation function. So remember we took data from the ticker symbol, multiple data. So what I'm going to do now is I'm going to take even more data, maybe like 6 or 7 stocks. Now there's a reason why I'm doing it. We'll come to that in a bit. The idea is to compare lots of other things with this data. So I'm going to do Apple, Coca-Cola, SPY. So I'm going to add some IBM. Get the spelling right. IBM, and I'm going to do Disney, and I'm going to do Microsoft, MSFT. So let's do these stocks. Basically got the stocks here. So let's take this one, and I'm going to copy paste this so I get the close data of all these stocks. And then I'm going to plot the graph as well. So we've got all these stocks here. So now what I'm going to do essentially is calculate percentage change for all of these. So what I'm going to do is just like what we did before, we're going to do close dot percentage change, underscore change, and we're going to drop the NAs as well. So we can remove all those other things. Then I'm going to do ret.head, so I can understand what's going on. So drop NA. Sorry about that. So there you go. So basically we've got all the data of the returns, so the percentage change of all these stocks. Now let's do the mean, and we can just do the ret.describe to get all the information from that. So there you go. So we've got the count, we've got the mean, standard deviation, minimum and maximum, and all those other information. So we can also transpose this as well. So let's say I want this column to be here and this column to be there. So one of the things that I could do is use the transpose. So I can just do .t, and as you can see, the count is now on the top side and the stock prices are on the bottom side. So if I just want 2 columns, so I can just do .lock. So I'm just gonna copy this, and then it'll be much more easier if it's in a different line of code. So I can do .t.lock, and then I can do the colon, comma, mean, just the mean, and just the standard deviation, and that's it. So basically we've got just the mean and standard deviation of all these stocks. So let's save this to a thing called summary. I'm going to just call the summary, and then there you go, we've got all the summary. Now we can also analyze this return just as we did before. Summary mean, create a different column. Summary mean equals summary mean multiplied by 252, and summary standard deviation equals summary standard deviation asterisk np.sqrt bracket 252. So now let's do the summary. So now we've got, from the daily, we've got annualized mean and standard deviation of all these stocks. So the reason why I'm doing this is I want to compare the risk to reward of basically all these stocks in one go. That's exactly why I'm going to do this. So in order to see that, it's a graphic representation will be more ideal. So let's do the x-axis as standard deviation and the y-axis as the mean return. So summary dot plot. So this time I'm going to do a scatter plot. Dot scatter. Going to call x equals standard deviation. And y equals mean. Then obviously the fig size bit. Fig size equals 12,8. S equals 50 and font size equals 15. So those are like the sizes of the scatter and also the font size as well. So and then we've got the summary dot plot, and now I want to annotate it. So I want to annotate the different mean, and the dots should be far away from a certain point so it doesn't create lots of issues. So I can just run this and basically you get all this. So what I want to do is I want to annotate which one's which. I want to do which one is Disney, which one is Microsoft, which one is SPY. So for that, what I'm going to do is I'm going to create a for loop. So I think this might be challenging for you initially, but I'm just going to write here for I, I'll just do it here instead. So for I in summary dot index. So basically it says, so I starts from 0, 1, 2 all the way to the number of indexes. So here 1, 2, 3, 4, 5, 6 to 6 indexes, and then so this is the column, this is the format. You can do plt dot annotate. So that's the annotate function. So the annotate function helps you plot the value. So we need to plot I, and then xy equals the location of the standard deviation and also the location of the mean. So summary dot lock bracket I comma std. I want to do plus 0.02, so there's some space where we annotate that thing. 02 comma summary dot lock. We also need the mean, so bracket again I comma mean, again plus 0.02 plus 0.002, that's a bracket, and I'm going to give the size of it, so size equals 15. So now let me, so there you go. So we've got the SPY, Coca-Cola, IBM, Disney, Microsoft, and Apple. So now let me label the x-axis and the y-axis. So plt dot x label, so call it annual risk or standard deviation. Font size equals 15. And then from that, let's see what we get. So basically we've got annual risk here. So I'm going to copy this and paste it, and then y label equals annual return. Nothing much changes there. And we got the plt dot title. The title of the graph is risk per return. And again, font size equals, let's give it a bigger font size, equals 25. So there you go. You can do the plt.show bit as well if you want. So the risk to return graph, annual return and annual risk. So you can see the best, so Apple has got massive returns, but as you can see, the risk is also quite high. So let's compare Microsoft and Disney here. So here the risk is almost close by, it's between 24 and 26, but Microsoft has given us a bigger reward. So if I have to choose between Disney and Microsoft, my obvious choice will be Microsoft. So one of the common things you can see here is that as you take more risk, you are having more reward, and that's what you want to have when you're creating financial strategies. More risk means more returns. But if you're taking too much risk for a smaller return, then it's pretty silly. Say for instance here IBM, you're taking massive risk of more than 0.22, but your return is less here. It's like less than 5% here. However, here on the SPY, you're making huge return, maybe like 12% return, but with minimalized returns. So this is pretty much the theory what Warren Buffett was saying on investing in S&P 500 index, because to a certain extent the long term it kind of beats the market, but to another extent it's also to control the volatility. It's much more easy for you to digest a small risk to get a better return. So again, if you're comparing SPY and Coca-Cola, they almost come to the same range of risk, but then the reward of SPY is much higher. So if I have to choose between SPY and Coca-Cola, I would choose SPY. If I have to choose between IBM and Coca-Cola, I would choose Coca-Cola, because Coca-Cola gets bigger returns with a smaller risk. So that's how it works. If I want to focus more on bigger returns, then I can always go Apple, but it comes with a price, and that price is that the standard deviation or the risk associated with it is quite high. So I know this for loop might be quite challenging for you, so I'm just going to explain it in simple terms so you guys kind of understand it. So let's call it fruits. So call it fruits. Let's call it apple, banana. It doesn't matter. Apologies for the spelling mistake, but I'm just trying to get you to understand what it's all about. So we got fruits, and we've got three elements in the fruits. So if I say for I in fruits, then I put a column here, and then I do print I. So what I get is apple, banana, and manaba, and mango. So for the first time it goes to the loop fruits of 0, and then it prints apple, then it goes fruits of banana, and then fruits of mango. So if I type in fruits of 0, what I basically get is apple. So if I type fruits in 1, what I get is banana. So that's what happens here. So for every time the fruit gets repeated, it repeats the first one, and then the second one and the third one. So that's basically what a for loop does. It actually goes through that process of looping the whole situation, really. So that's exactly what we've used here as well. So we've actually gone through for the for loop of all these stocks, and then we annotated it one by one. So then we annotated it, and you see that plus 0.02, that's just the spacing and also the size as well, and then we just labeled the graph. So hope you got a gist of that. So let's now discuss covariance and correlation. So what I'm going to do is I'm going to just change the cell type and write it markdown. The whole idea is just to give like a heading. So if I put more columns, letters will be smaller, and if I put just 2 columns, it'll be slightly bigger. So I'm just going to write there correlation and covariance. If I do that, basically gives you a heading. So I don't remember if I said that, but there's like, if you want to leave a comment or something, you can just give like a hash symbol, and basically that's a comment. So anyways, I'm just going to run that as well. Let's see what return is again. So that's a return. So now let's do the covariance, which is pretty simple. We just do ret.cov function, and if we put in shift.tab, it basically says covariance of columns excluding NA or null values. So I run that, basically I have got the covariance of all the products right there. Similarly, I can do the correlation as well. So ret.correlation, and you've got the correlation as well. Now these are just numbers, it's easy to see the numbers, but it's quite difficult to understand it for a layman term. So graphical representation is always good. So what I'm going to do is I'm going to create like a heat map for this correlation and covariance. So for that we need to import a library. So we're going to put import Seaborn as SNS. So we're going to use it to use this library to create a heat map, but we'll see it as we go through. So we're just waiting for it to import the library. So as that goes by, okay, now we have actually imported the library. So we'll just do the figure. So plt.figure, fig size equals 12,8. And then we're going to use this SNS with the Seaborn file. So sns.set. We'll do a font scale, so we know how big the letter should be. Scale equals, let's say 1.4. And we shall do the heat map. So sns.heatmap function. So let's see if I can get the shift tab. Yeah. So basically what it does is plots rectangular data as a color encoded matrix. So that's what we're going to do. So we're going to do the correlation. So ret.core function. And now I'm going to give the color codes for that. So cmap will be equal to reds. And annotate, we like to annotate what's been written there, so that'll be true. The other annotate.kws equals, we'll mention the size. Size colon 15, and then vmax equals 0.6. So you can change the vmax depending upon how you want it to be. So I know this is like a complex line of code, but in reality it's just nothing. You can just copy paste it. But I'll just plt.show. I'll just run this so you get a general idea of what's going on. Okay, we've got an error, so let's see what has happened. I've got the graph as well. So I think it's something to do with the annotation. So let's see what's wrong here. Not KWS size colon 15. Oh yeah, there you go. This is the problem here. So this should sort out the issue. So there you go. So basically we've got a correlation graph. Regardless, what I want you to do is, just in case you have errors or bugs coming up, I'll leave the download link for the entire code of this whole program in the description box, so you can just download it, and then if in case you have a small error here and there, you can just compare it and copy paste it and run the Python file, save the Python file and run the Python file here in Jupyter, and it should be just fine. So before you run the Python file, make sure that Python file is on the folder, and just go to that folder and open it and run all, and then you should get all these things. But if you have any doubts or clarifications, you can always leave a comment or contact quantprogram@gmail.com. So coming back to the correlation graph, so we've got lots of stocks here. We've got the Apple, Disney, IBM. So SPY is basically S&P 500, so we just got the 500 top stocks of the US market. So it's expected SPY to have a high correlation to all these stocks, because it represents a general market. So if I can see the SPY's correlation to SPY is just 1, so that's expected. The SPY will be correlated to SPY to 1. So when you pick a portfolio of stocks, one of the most important things that as a quantitative analyst or a quantitative trader that you do is that you need to have stocks which are extremely uncorrelated. So in that way, if one company goes down, the other company is immune to that thing. So if I can look at the least bright one, so that's Apple and Coca-Cola, that's only got a correlation of 0.34, which makes sense because Coca-Cola is in the cola industry and Apple is in the technological industry. So adding Apple and Coca-Cola is a good selection. The other one will be Apple and Disney. As you can see, it's just 0.41. Anything above 0.5, but these are all high correlated stocks. You can always find stocks which are less correlated. So you can see these 0.5, 0.5. So I would recommend going anything below 0.5 so that you have kind of like a not so good correlation in the stocks. But SPY, it'll always be highly correlated because SPY represents a general market index. So now you've got two information. So you've got basically the information from the risk to return from a risk to base standpoint, and also you've got the correlation and covariance. So the first challenge in this video is basically what you've learned so far. So I want you to download 20 random stocks from the Yahoo Finance. Like, can be any of the 20 random stocks that you like, you don't like, or just some names. It could be a fan company, or it could be anything. Just download the 20 random stocks, and then I want you to calculate the risk and reward potential, which is similar to this one here. And then I want you to compare the covariance and correlation. And then I want you to find the best 5 to invest in based on the assessment of the covariance and correlation, and also the standard deviation and annual return. There's no right or wrong, but I've given you a example on what kind of stocks you can choose. Like, for example, here I'd rather choose SPY instead of Coca-Cola or IBM. Here I choose Microsoft instead of Disney. So, and if I want, I can add an Apple. I know it's high annual risk, but then it's also getting a higher reward. So there's no right or wrong. I just want you to think like a quant and come up with all these things, all these numbers, and try to figure out what you like and use that as a tool for you to invest it in the long term. So now we've gone through that. Now let's go to something else. So we'll actually discuss now simple returns versus log returns. So I'm just going to do the cell markdowns as well. Call it simple returns and log returns. Simple returns and log returns. So let's create a random data frame. So I'm going to just create a data frame called df, and then I'm going to use the pandas data frame and data frame. And then I'm just going to create a new list of data. So I'm going to call it index equals 2016, 2017, 2018. And then I'm going to comma data equals colon 100, 50, 95, and then columns equals price. So I'm going to run this, and then let me just call df. So basically I've got the price 150, 95, 2016, 2017, and 2018. So simple returns would essentially be equal to df dot percentage underscore change, which we did before. Change, got the function, and I'm going to drop the NA as well so it looks more clean. So drop NA. Just call simple returns. So basically we've got simple returns in 2017, 2016 obviously there's no returns because it's NAN. So 2017 it's 50% decline, and then 2018 it's a 90% increase. So that's a simple returns. Now if you take the simple returns mean, simple returns dot mean function, this is what we get. So, but in theoretical terms, when you start from 2017, it's actually gone from 100 to 95. So it's actually minus 0.5, but here it's actually noted as 0.2. So that's basically the problem with simple returns. So simple returns doesn't calculate it from the beginning till the end kind of perspective. So if I take this data, the 0.2, sorry, let's say our starting price is 100 here. They're saying the average return is 0.2. So if average return is 0.2, it should be 100 asterisk 1.2 asterisk 1.2, which should give you 144. But it's not 144. The end result is 95. So this is where the log returns come into perspective, because mean returns are very misleading. So I'll write here, mean returns are misleading. That's crazy. So that's the problem with calculating mean returns. So that's where log returns comes into perspective. So let's calculate the log returns. We can use a numpy platform. So library. So np.log and then bracket. So df divided by df.shift1. So we have discussed both shift1 and the divide by, obviously you know that. And then we're just going to run this. So there's the NAN, which is a drop NA, and then we've got minus 0.693 and 0.641854. So I'm just going to drop NA as well, so just to avoid confusion. So now we've got the log returns of 2017 and 2018. So I'm going to save this as log returns, and I'm going to put in log returns. So there you go. Now let's calculate the mean of the log returns. So log returns dot mean. So there you go. So we've got minus 0.02. So now let's calculate it from an arithmetic perspective and see what we get is correct. So the starting price was 100. So 100 asterisk, and use the NP function to calculate the exponential. Exponential log returns dot mean asterisk 2 years. So yeah, dot mean. So we're taking the log returns mean, exponential it by 2, and that's why we do the asterisk function. Run that, and you get basically 95, which is the ending price that we have in 2018. So I hope this makes sense on why log returns is more accurate measure of the returns as compared to simple returns. Most people focus on the simple returns, but as quantitative traders we need to understand the importance of log returns. So I hope you got a gist of the idea on simple returns and log returns. So now let's go and do a first simple moving average, how to calculate a simple moving average. So for that, what I'm going to do is I'm going to download the data, and then I'm going to calculate the simple moving average. So let's just focus on SPY. So I just want to start simple, and then we'll go to complicated perspective. So let's go up and then do the YF bit. Just going to go down, and then I'm just going to paste it here. And I'm going to ignore the start and end. So what happens is that you get whatever data is stored from the beginning till the end. So that's set by default. So if I look at shift into tab, and then if I look in the plus one, so start by default is none, end by default is none. So if I go down, default is 1900 and end default is now. So I'm just going to do it, and then I'm just going to type in SPY. Let's call it SPY as well. So it's downloaded, so let me see what SPY brings. So we've got SPY and all the data in it. So I just want the SPY.close, and I'm going to call it little SPY. So programming generally is case sensitive, so you have to be really careful in identifying that. I'm just going to run that. So now let me see SPY. So there you go. So we've got SPY data, but it's not in a data frame perspective. So I'm going to do SPY.close to underscore frame, and then store it there. There you go. So we've got the SPY data, the close and the date from 1993 to 2022, January the 5th. So let's calculate the, just plot the graph. So I'm just going to do SPY.plot, just like we did before. Fixed size equals bracket 12,8, comma font size equal 15. And then plt.legend lock equals upper left, comma font size. So the reason why I'm putting upper left is that what the line is on the upper left side of the graph. So font size equals 15, plt.show. So there you go. So we've got the SPY graph here. So I need to calculate the moving average from this data. So what I can use is a thing called rolling function. So the rolling function, basically what it does is that it calculates the past X period. So I'm just going to type in so you get an idea. So SPY.rolling, and then windows equals 10. So I'm just going to put Shift and Tab, see what SPY rolling's definition, correct definition is. Provide rolling window calculations. So I'm just going to run this. Spelling of windows. Window. Apologies. And then let's call SPY roll. So we basically got this here. What I'm also going to do is I'm going to calculate the mean of the rolled values equals SPY underscore roll. Now let's call SPY underscore roll. So there you go. So we've got the 1993 data, and then it basically calculates the average of the other rest of the periods. So as you can see, the first few periods it's missing because it takes 10 days for you to calculate the average. So let me show you the 15 days, head of 15, so then you'll get an idea. So it's NAN, 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 and then comes the first number, the second number, the third number. So we're going to use this, and we're going to actually calculate the moving average. So we can also do the median as well. So if I can do comma 10, comma mean, comma median, sorry. Median is not defined. Oh yeah, it's comma, yeah. So there you go. So you can actually get the median values as well. So the mean and the median are quite different. So mean is like dividing the periods by the past 10 days, and the median is like taking the mid price of it. So I'll just go into Google and type in mean versus median, so you get a general idea of it, the correct definition rather than anything else. So mean is the arithmetic average of a set of numbers or distribution. Mean is computed by adding up all the values and dividing that score by a number of values. The median is a number found at the exact middle of the set of values. So I hope you guys understood the correct definition. I don't want to give a different answer and sound like an idiot. So you can use many of these things. You can also calculate the maximum of the past 10 days. So I can just do SPY.rolling, and then I can do .max. So it gives you the maximum value of the past 10 days. So yeah, so it'll take the maximum value of the 10 days and keep printing it. So you can see it's 47748, it doesn't change, and because of the last few days, because we haven't got a value bigger than that. You can also use in the same SPY rolling a thing called minimum. So minimum is that I need at least 5 data to start calculating. So we know the window is 10, but by setting a minimum periods equal 5, it calculates from the 5th period. Periods equals 5. So as you can see from the 5th period, that started calculating it. So let me just do dot head 15. So as you can see, it's set as a default value 45, 45, 45, 45 max, and then it changes at 44. So yeah, so that sets up the minimum. You can activate that specific periods. So now let's first calculate the 50-day moving average. So what I'm going to do is, let me see, just what did we save it as? SPY roll, SPY, I think it's SPY. So there you go, we've got the SPY. So I'm going to create a new column. So SPY, as you know, to create a new column is pretty simple. We do SPY and SMA 50 equals, we're going to do the exact same thing that we did here. SPY.rolling. So minimum window is 50 and minimum period required is also 50 because we're doing a 50-day moving average, and then we're going to calculate the mean of that. So let's run SPY. So there you go. So we've got the SMA 50. If I do SPY.head 52, we'll get the first calculation. So there you go. So first moving average is calculated on this specific date. So just going to delete this off, but anyways, you've actually got the data of both the SMA 50-day moving average and the close data. So similarly, we can create 200-day moving average or 100-day moving average, it doesn't matter. So, but anyways, now I'm going to plot the graph. So we get both the SMA and the closing price on the same thing. So I'm just going to copy this and I shall paste this here. I'll just run that. So there you go. So we've got the orange line in SMA and the blue line, which is essentially the prices. So yeah, there you go. It was pretty simple calculation of the SPY. So similarly, you can do the 200-day moving average as well. So I'll just do that one as well. So we are done with it. So we're going to paste that and I'm going to do 200 here. 100, and I'm also going to copy paste this one as well, so we won't have to worry about the graph. So we're going to call it 200, don't forget that, because otherwise it's going to override that 50-day moving average. So what's going on here? Placement implies 1. So I think I'm just going to cut this off first and then run that. 2 placement implies 1. Oh yeah, so the thing is that now we've got a new column which will SMA 50. So you should only have one column of the close. So I have to specify that. So SPY.close is what we should do. So before we only had one close, so there was no controversy in that. Now we have 2. We've got the close and the VFG SPY. So we need to mention that. So now we've got it, and then let me just run SPY. There you go. So we've got the 200-day moving average and the 50-day moving average. And now if I copy paste this, it should go through. So there you go. We've got the 200-day moving average and we've got the 50-day moving average. As you can see, the market went down the 200-day moving average in the Corona crash and also during the financial crisis crash. And generally, the market has been on an uptrend. So yeah. There you go. So now you know how to calculate the 50-day moving average, 200-day moving average, and to plot it. So here comes challenge 2. Remember the 5 stocks that you did for the covariance and correlation and also the annual risk and standard deviation. I want you to take that and I want you to plot the graph of all these 5 stocks exactly like this. Calculate the 50-day moving average and 200-day moving average and see the graph. And see for yourself if you can find some kind of a specific strategy. So like here, if I see the 200-day moving average in the SPY, I can see that the market generally goes above the 200-day moving average. So you can use that as a signal. If the market is closing above the 200-day moving average, you can go long. And if the market is closing below the 200-day moving average, you can go short. So just come up with the ideas. I'm not asking you to do the strategy, which we'll come to it in a bit. But as of now, I just want you to draw the graph. So we'll take it one by one, step by step, and as you go by, you'll be more equipped of doing this. So let's now do the EMA as well, because we've done the SMA. So let's now start to figure out how to do an EMA. So EMA is pretty much the same thing as an SMA, but you need to change some of the words or the format. So instead of close dot rolling, we write in EWM. So I'm going to type in EWM. I'm going to call this EMA. Let's call this 100 instead. And then minimum periods is 100. And then for the window, we'll write in span. So span equals 100. So let's put shift and tab and you'll get the correct definition of this function. So span float none, minimum periods none equals 0, provides exponential weighted functions. So let me just run this and then type in SPY. And basically you've got the EMA 100 as well. So let's plot the exact same thing here. And now we shall get the EMA on the graph as well. So there's EMA 100 in the graph as well. So there you go, that's the EMA. The other things we can do is, since we've got the columns here, we've got the days and the quarters and things like that. So if I want that to be mentioned in that table, one of the things I could do is I could do SPY, and I can call it day equals SPY dot index dot day underscore name function. So this will give you all the days of that specified date. So it'll be Friday, Monday, Tuesday, Wednesday, Thursday, and that goes on. So similarly, I can do the quarters as well. So I can do QARTER equals SPY dot index dot quarter. So if I type in SPY here, we basically get the quarters as well, the fourth quarter, the first quarter, and so we'll restart the whole thing. So we'll do SPY, and then we'll do SPY dot to underscore frame equals SPY. So now we've got the SPY here. So one of the things we need to do essentially is the days. As you can see here, the 30 and 31st is missing because those are Saturdays and Sundays. So what I'm going to do is I want all the days in that data frame. So one of the things I could do is use reindex. So before we use reindex, I'm going to create a variable all days, and I'm going to use the pandas data frame. So pd dot date underscore range. And I'm going to mention the dates just to make it more simple. So let's do start equals 2010 12 31. Just going to give this column here, and then a comma end equals 2020 0101, and then frequency FREQ equals D. Then let me just write in all underscore days. Invalid syntax. So where have I gone wrong? End is right. Oh yeah, here, the comma. So we've got all the days. Now what I'm going to do is I'm going to reindex all these days to this SPY data frame. So I'm just going to print the SPY here. So we've got the SPY there. So I'm going to do is SPY dot SPY equals SPY dot reindex, and bracket the days mentioned. So days, it's only between these 2 days. You can keep on, you can give out different days as well, and I'm going to give in all days. Let's see what we get for SPY. So as you can see here, there's NAN, so that's for the first, and the second it might be holiday, and obviously there'll be Saturdays and Sundays and things like that. So in order to replace this NAN, one of the things you could do is you could do forward fill and backfill. So basically, forward fill is that it takes this day and prints it on the first and the second. Similarly, it goes on like that. So what I'm going to do is I'm going to do SPY dot fill NA method equals going to do ffill. So that's forward fill. I'm going to run that. So as you can see now, you can see 125.7 is printed on the 1st of January. Similarly, you can do the backfill as well. The only difference being it takes a future date and copies to the other one. So I'll show you there. So as you can see here, it copies this value 127.05 and prints it on the previous day. So 127.05 was the 0103, and it prints here. So the forward fill takes the previous value and puts in, the backward fill takes the new value and prints it on the back side. So if you can see here on the 2020, the 1st of January, there's NAN because there's no future value for that. That's why we don't have the value for that. So that's forward fill and backward fill. If you want to do something in managing data, especially when you download lots of data, there will be issues like that. And if you want to take in Saturdays and Sundays and holidays into picture, then that becomes a source of concern as well. So another thing to notice is we have got daily data for most of this. So if in case you want weekly data, one of the things you could do is you could just mention 1 week in it. So all I have to do is I just have to change the interval to 1 week, and we should get that sorted. Let's just remove the brackets here and put the brackets there. So if I can go to the shift and tab here, once I go in and just click on the plus sign, if you can go down, you will see interval, valid intervals are 1M, 2M. So these are the formats. If you want 15-minute data, if you want 1 month data, these are the formats that you want to fill in. So intraday data cannot extend last 60 days. If you're working with intraday data, then the maximum you can do is for 60 days. But the weekly and monthly, you can get a lot of data. So I'm just going to change it to weekly data just to show you guys what the weekly data is. So there you go. So you basically got 250108, and that's the weekly data. So now let's kind of find out things like the maximum drawdowns, the returns, daily returns, the cumulative returns, the cumulative maximum returns, the buy and hold returns, and things like that. So after that, we'll proceed to the strategy. So I'm just gonna change this to Markdown and type. Yeah. So in order to calculate the cumulative returns, first let's go into downloading some data. So we'll just download Apple's data. So I'm just going to call it apple equals yf.download AAPO. Okay, so now we've got the Apple data. So if I can just see the Apple data, what we basically got is this. So I just want the Apple's close data as of now. So Apple close to_frame, and then I shall store it into Apple. So I'll override the Apple data and store it in store this close data there. So what does it say? Okay, there's no closer, it's just capital C there. So there you go. So then I'll just run that. There you go, we've got the Apple close data. So let's create a new column for the daily returns. So we'll do Apple. So if you do Apple.close, we've basically got the close data. So what I'm going to do is I'm going to create a new column. So we're going to do Apple and then daily_returns equals np.log brackets Apple dot divided by Apple dot shift of 1. So we should get the new data in Apple here. So there you go, they've got the daily returns of Apple. So the first one will be NAN because there was no previous data for that. So basically what it does is that it divides the previous value and calculates a log of returns of that. So we basically got -5.3, -7.6, and there it goes. So let's remove the NA value. So on 12.12 there's an NA value there. So I'm going to drop down all the NA values. So Apple.drop NA in place equals true. I've got to discuss this before, but just a revision sort of a thing. So there you go. So we have removed that one. So we've got the daily return. So now let's take the returns, the buy and hold returns, like the sum of the returns. So basically all we need to do is apple.d_returns dot sum. So basically it calculates the entire sum of the daily returns, and this is the value that we get. So now let's also calculate the what would you get if you had invested $1 into the stock on 15th of December 1980. So for that we'll just again use the numpy expander and we'll use exponential, and then we'll do a apple dot daily_returns dot sum. So $1 invested in 1980 will be now $1,340. So this is the same methodology that we are going to use. So let's create a new column. So Apple cumulative returns, CUMM returns, cumulative returns equals apple dot d_returns dot CumSum cumulative sum dot apply bracket np.exp. Let's run the Apple. So there you go. So finally we've got 1340.1066. So that's what we calculated here as well. So we've just made it from a column perspective. So $1 invested on the start of the day will go to 0.94 and then 0.87. It'll go down, but then finally it kept on going up. So we can plot these graph. So I'm going to plot the graph of this. So it'll be Apple dot, just going to copy paste that. Cumulative returns dot plot. We discussed this before. Just plot fixed size equals bracket 12,8. Let's give it a title. Title equals Apple buy and hold. Buy and hold. Font size equals 12. Then just do blt.show. So there you go. That's the Apple buy and hold cumulative return. So $1 invested from the beginning should give you all the way up to 1,300 something. So now let's do the mean, the annual mean return, the annual standard deviation and things like that. So we'll just need apple.daily returns. So that's d_returns, d_returns dot mean asterisk 252. That'll give us the average returns for the Apple stock. So that's annual average return is 17.5. So let's also do the standard deviation for that as well. So again, that is also pretty simple. We'll just change the std and then np asterisk np.sqrt and then 252. So we've got a standard deviation of 45%, which is quite high for Apple, but for the amount of returns we're getting on an annual basis, this is expected. So let's now calculate the maximum, cumulative maximum. The reason we're doing that is to calculate the drawdowns. So I'm just going to change the headlines here, I mean the markdown here, or just comment it. How to calculate drawdowns. Calculate drawdowns. So basically the way we calculate drawdowns is that we need to find the peak and the valley. So different methodologies have different platforms have got different methodologies. So for instance, TradingView, they calculate from the trade entry, but the real drawdown should be calculated from the peak of your strategy or your peak of where the stock is. So for example, here, the drawdown here in 2000, whenever that took place between 2010 and 2015. So we need to calculate the drawdown from the high of that and then all the way to the low. Similarly here, we need to get the high of it and then all the way to the low. So in order to do that, we need to calculate the cumulative maximum. So what's the maximum that it went high, and then from that we can actually calculate the drawdowns. So let's actually create a new column for the cumulative max. So CUMMMAX equals APPLE dot cumulative returns. That's what we call cum returns dot cumulative max. So that function basically gives us the maximum or a data frame or a series of axes. So I'm just going to run that, and then what you see here is the cumulative maximum. So for example, here the maximum was 0.94, the market went down to 0.87, but the cumulative maximum stayed there. So we can plot that in the graph as well. So what I'm going to do is I'm going to copy paste this one here, the entirety of this, but I'm going to plot both of these things. I'm going to plot the cumulative maximum and also the cumulative returns. So for that I need Apple, then I'm going to create a square bracket. In that square bracket we need two things. We need to get the CUMM, that's already there, so cumulative returns, and then comma cumulative max, and then close the bracket, double close the bracket, and then so Apple buy and hold cumulative max, so plus cumulative max and we'll just plot this. So there you go, you see that high. So we've actually plotted the high of each of the new high that it has created. So this can also be beneficial for you in future if you're trying to come up with a 52-week high or breakout strategy. So the approach is pretty much the same. So now let's calculate the drawdowns. So drawdowns pretty simple. So all we need to see, we've already got the cumulative maximum. So we take the cumulative maximum and subtract the cumulative returns. So we've got the cumulative maximum here, and then we calculate the returns by cumulative returns by 0.94 minus 0.87. So Apple, I'll call it drawdown. Drawdown equals Apple cumulative max minus Apple cumulative returns. Apple. So there we go. We've got the drawdowns. The first day drawdown is just 0%, and then you can see the drawdowns here. So for example, here the drawdowns again 0.00%, but that happened because of the cumulative returns and cumulative max being the same. So we got those things sorted out. Now let's calculate the drawdown, maximum drawdown we have in from a dollar perspective. So Apple dot drawdown dot max. So $213 is the maximum drawdown that we have had. So let's see when this maximum drawdown took place. I mean, which date did it take place? For that, all we need to do is apple.drawdown.max and use the idxmax function. So that basically takes care of finding out which date happened. So it happened on 2029/8. So one of the things I could, so let's see, I want to know the days where this drawdown happened. So I can do is I can use a .log thingy. So basically it's apple .log, and then I can do a bracket here, and then normal brackets, and then apple.index, because this is the datetime data is here. So we'll do index equals, just copy this one there, copy and paste. So there you go. So invalid syntax, where would I go wrong here? Oh, it's actually equal to. So there you go. So 2020 09/18. So we got the daily returns of minus 0.032, and there you go. So let's get the data of less than equal to, so we get an idea what happened. So as you can see, the stock price went from all the way from 115, just kept on going down. So you can see the drawdowns were picking up, and reached a peak of 213. So that's a dollar expression of the highest drawdown that has taken place. But how about percentage-wise? Because we always have to deal with percentage-wise. So let's calculate the percentage drawdown. So Apple, and then drawdown percentage will be equal to, it's pretty basic calculation. We just need to divide this thing by the cumulative max. So I'm just going to copy this one here. Just create a square bracket there, and then paste that. Divided by Apple of cumulative maximum. Then if I do the Apple, basically I've got the drawdown percentage as well. So similarly, we can do the Apple drawdown percentage maximum, which was the highest fall we've had from a percentage basis. So all I have to do is put a percentage here. So the problem is, because we've used a percentage, and percentage kind of creates a problem, so it's better off you do because Python kind of views percentage as something else. So one of the things you could do is you could just do the square bracket here, and then give some quotes, and this should give you, that's funny, percentage, and this should give you that 82% drawdown. We had an 82% drawdown. That's very high. So let's find out when that took place. That took place just by using the exact same thing we did before. That took place on 1997, 23rd of December. So let's also calculate the location of that thing. So I'll just copy, I'll just paste that. So copy paste this one here. So this less than or equal to is like a condition operator. It basically checks the condition. The other thing, the normal single equal to, is assigning a certain condition, like a equals 5, so 5 is assigned to a. However, when you say a equal to 5, it's checking whether a is equal to 5. So I'm going to run that. So you can see the drawdown just kept on falling. So now you know the difference between the drawdown percentage and normal drawdown. So from a dollar perspective, drawdown was high at $213, but from a percentage perspective, we had a bigger drawdown for this. So now this is expected in Apple because the amount of returns that you're getting is so high that massive drawdowns are expected. So these are some of the common things that you actually check when you do quantitative analysis of a specific stock. Like you check the standard deviation, you check the drawdown from a dollar perspective, you check the drawdown from a percentage perspective. And remember we said we compared that graph of correlation and covariance and also the annual return and annual standard deviation. When we compared all those stocks, Apple was the best performing, but it had come with a higher standard deviation. So standard deviation is different from drawdown. So standard deviation is like how far does it normally go from the mean. So mean is like what are the typical values on a daily return and how far can that go, where is the majority of the deviation from that mean. So drawdown on the other hand is different. Drawdown is like how far has the stock collapsed from the top of the top of its prices. So all these metrics are quite important when you analyze the stock, but then what happens to most people is that they don't bother doing all this research, and luckily with coding you can actually just download the data and pick up all these things with just a few lines of code. Let's now create the first strategy. It's going to be a simple moving average crossover, but as we go through this you'll get a general idea on how to create better strategies. So first, let me just write it down. SMA strategy. I'm just gonna do SMA strategy. Okay, so we've got the Apple returns right here. So what I want to do is, I don't want all these data. So what I'll do is I just need, now it's 2021. So I think from 1991, 2001, 2011, 2021. So I'll use the same thing and I'm going to copy paste it, and I'm going to do greater than equal to 1991 01 01. So that's the data from 1991 to 2022. I'm going to save this to data. So I also just want the close as well. So if I go and look at the data, basically you've got data. So I'm going to convert that to data equals data dot to underscore frame to the data frame, and let's see what the data is now. So there we go. We've got the data from 1991 to 2022. So let's create two moving averages. So what I'm going to do is I'm going to create 50 moving average and a 100-day moving average. So SMA underscore S equals 50. And SMA underscore L equals 100. So the short period moving average is 50 and the long period moving average is 100. So we've discussed how to create a moving average. So that's basically by using the rolling function. So let's create the first data. SMA underscore S equals data dot price dot rolling SMA underscore S dot mean, and we shall also create data SMA underscore L. It's also the same thing here. We'll just copy paste that. So let's copy, let's paste that. Okay, so we've got an error. So yeah, so it's not price, it's actually close. So close, close. So if you figured it out early, congratulations, you are in the right path of learning path of this video. So let's see the data. So you can see SMAS and SMAL. Obviously, the first few periods are can't be seen because there is no SMA can't be calculated unless the first period comes into perspective. So let's plot this now. So we'll just do the data dot plot. So obviously you know how to plot this before. So fixed size equals bracket 12,8, and then comma title equals Apple SMA. So I'm going to show you how to write some of the things on the title. So what we're going to do is we're going to do this specific curly bracket. Then I'm going to give a separation, and then SMA, another curly bracket there, and then I'm going to do a format function, and I'm going to type in this SMAS and SMAL. So SMA underscore S and SMA underscore L, which is basically these 250 and 100 here. And then I'm going to give the font size as well. So what this does is it replaces this Apple SMA, and inside here there will be the SMA 50 and SMA L. And that's where the curly brackets comes into perspective. So font size equals 12. Just run that. So there you go. So we've got the SMAS and SMAL. I know it's like very specific, you know, it's like you can't see it properly. But what I'm going to do is you can do another thing as well. You can just copy paste it and then just specify which year you want to do it. So if I do data.log and bracket, let's say 2016. So what's going to happen is we're going to get the only 2016's data. So there you go. You saw the 2016's data. So this is the blue is the closing, and then SMAS and SMAL is the orange and green line. So you can basically test based on a specified year as well. So we're just going to do the whole year for the past 20 years, but I just want to show you how to do the other things. So anyways, we've got NA here a lot, so I'm going to delete off those data so it doesn't create any issues for us in the future. So data.drop NA in place equals true. So the data now. So there you go. The NA values have been kicked out. So when do we need a position? So the position is only taken when the long period SMA there's a short period SMA. So if SMAS is greater than SMAL, we go long. Otherwise, we go short, which is -1. So let's create another column called position. Data position equals, so here we can use a numpy's library, and we can use a condition np where, and where data of bracket SMA underscore S is greater than data of SMA underscore L, then we go long. So for that condition we put 1, and then if not we go -1. So let's run this and let's see the data now. So as you can see here, the SMAS is greater than SMA1, so we go long. So there'll be longs and -1s as well, so obviously it hasn't happened multiple times. So now let's plot this. So what I'm going to do is I'm going to take this one here. Let's take this one here, data.log. So I'm going to copy this. I'm not going to make massive changes as such, but what I'm going to show you is I'm going to do the data.log, but instead of 2016, I don't want everything to be printed. So I'm going to do this one and then the date, and then I want the SMA underscore S, comma, underscore S, comma, SMA underscore L, SMA underscore L, comma, position as well. So I'm going to do position. So I'm going to do data.log SMA underscore S, SMA underscore L, and position, and then plot fixed size, font is equal to 12, SMAS, SMAL, Let's see what we get. So as you can see the precision here, 0, 0. So it ranges from -1 to +1. So I want to make a small change because the graph is so big. What I'm going to do is I'm going to do a secondary Y position. So you'll see what that is in a bit. So what I'm going to do is I'm going to comma here, comma secondary underscore Y equals position. So the reason why I did that is I want like two separate things. So you see this -1, that's when we went short, and you see this +1, that's where we went long. So you can see we are changing the positions every now and then. So if I can just put into a shorter time frame, so this is for all the data. So if I just put in 2016 like I did before, let's do 2016, let's see if it still goes through. So there you go. So in this case, the SMA, the short SMA went down, so we went short, so that's a -1 here, as you can see here. And then we went long when this blue line crossed above the orange line, and then similarly we went short and we went long, and that's basically it. So we've just plotted the graph, and I just reduced the time frame to just 2016 for you guys to see visually what's going on. So far we've got the position. Now what we want to do is we need to backtest this. So we need to know the returns, and also we need to compare the returns as well. So just like before, what we're going to do is we're going to calculate the buy and hold returns. So we know how to calculate the buy and hold returns. It's just basically data of returns. I'm going to say buy and hold, so I'm going to say B and H. Buy and hold equals np.log data dot close dot divided by data dot close dot shift bracket 1. It's going to run that. So let's see the data. There you go. So we got that. Now the data of the strategy as well is important. So of buy and hold, so we need to know the buy and hold returns as well. So let's calculate the data of the strategy buy and hold. So I'm going to name it strategy B and H. So this is the strategy of the SMA, so we're just going to call it data of strategy. So data of strategy is basically the data of returns of B and H multiplied by the position. So because we're going long, we've got a specified position, right? So data of returns B and H, and multiply by, which is the daily returns, and multiplied by data dot position, which is basically this one, dot shift 1, because it's the previous position we need to calculate for the returns. So far we're clear with the data of strategy. So let's run the data. So we've got the data of strategy and then the data of the buy and hold as well. So the reason why this is different is that in buy and hold there's basically no difference. It's like you're going long continuously. You're not going at short position. On the other hand, for the strategy, which is the SMA strategy, we're actually going short when the SMAS is lower than the SMAL. So this kind of get depicted to this side of the fence. So now let's drop the NA values, obviously. So data.drop NA in place equals true. So that's done. So we've dropped the NA. So now let's calculate the sum absolute performance. Let's calculate the absolute performance of both these buy and hold and also the strategy and compare the two. So we'll do the returns. So we need two square brackets, by the way. So we need returns B and H, buy and hold, comma, what's the other one? Strategy. So we've got that one, dot SUM. So sum of both of them. So strategy, we had 1.95, returns buy and hold, we had 6.05, which is pretty good because the buy and hold actually beat the strategy of 50 to 100-day moving average. But we need to compare it with the other factors like the drawdowns and the standard deviation, because that's quite important. Because remember, when we studied this, we really saw the drawdowns come back to almost 80%. So just because the returns is higher for buy and hold doesn't mean it's the ideal strategy. So what we're going to do is we're going to calculate the absolute performance. So for that, all we need to do is we just do .sum, .apply, np.exp. So I'm going to just give in a bracket to show you so what $1 investment will be. If I do that, so $1 investment will be 426 in the buy and hold, and the strategy will be 7. So that's the absolute performance. So let's also calculate the standard deviation of both of these. So I'm just going to copy this and I'm going to paste that .std function. We've done this before. .np .sqrt 252. So that gives us the annual standard deviation. I'm just going to type in there annual std. So as you can see, the buy and hold and the strategy has similar, close by similar standard deviation. So in this strategy, the 50 crossing over 100, and we going long if the 50 cross 100, and we going short if the 50 closes below the 100 strategy, is not really that beneficial. So if I look data.close.plot fixed size equals bracket 12,8. So we've got a general bias to the upside. So how about I create a strategy in such a way that I don't go short? So that will be an interesting change. So I'm going to create a new markdown here. So strategy adjusted with long bias. So I'm not going to take a short position because I believe that there's no need to be participating in a short position because the fundamental bias is to the long side. Why should I trade? Why should I expose myself to the choppiness of the short side? So what I'm going to do is exactly the same thing that we did before, except the position will be different. So let's do data of position is np.where SMA squared and SML just 1 or else 0. So I'm going to call this position 2. So we'll run that. So we've got the data position 2. Now let's calculate the strategy returns as well. So we'll call this strategy 2. So strategy 2 is returns buy and hold into data.position2 .shift1. So let's run that. So now we've got the strategy returns of the other variable as well. So we're just going to drop the NA, drop NA in place equals true. So now let's compare them both. So we've got the data of returns buy and hold, and we'll compare that with the strategy 2. So there you go, strategy 2 has got slightly better returns, and also let's see what $1 will be. So returns buy and hold and strategy 2. So we've got 53, 419 as compared to 426 and 7. So how about the standard deviation? That's what we've been looking for, right? Where we able to reduce the risk by reducing the standard deviation. So I'm going to go down and I'm going to place this here. Just calling standard deviation 2. So we had 44% standard deviation. Now our standard deviation is 34%. So we were able to completely reduce the risk, and by taking a long bias, we were able to get much better returns as compared to the going short and long together. So from this we can actually conclude, based on quantitative trading analysis, that strategy 2 is better than strategy 1. So that's how you create great strategies, by making certain biases, making certain changes, and this is where backtesting and coding really helps you. You can also compare different things, like let's say instead of this comparing it with buy and hold, we can actually compare it with strategy and strategy position. So let's do here strategy. So you can see 44% standard deviation for the first one, 34% standard deviation for the second one. So SMA strategy is pretty decent. The drawdowns might be smaller as well. So you can also calculate the drawdowns for the buy and hold and the strategy 2 for the long only bias, and see which one performs better. I am pretty sure the drawdowns might be better for the long only bias, because we're not expecting, we're not going long if the market's as compared to buy and hold when we're always long. It's only if we're above a certain moving average we're actually going long. So the drawdown, I think, if I can remember, our drawdowns was like 80% or something. I think for the long only bias, the drawdown might be better, or not might be better. So you might have to research that. So that's the other challenge that I'm going to write down here. So this is our other challenge as well. Okay, so now let's move into creating a first function. So you see many of these things like std function here, or a mean function, or a sum function, or many of the functions there. So we can create our own function. So the advantage of creating our own function is, remember we did this line by line for every single code, every single strategy. We can actually minimize that. So I'm just going to change this markdown and call this creating function, creating our first function. Okay, so let's create a first function. So it's basically everything that we just did before, but containing it in a function so that that function does that job. Like I said before, functions like, just like your hand has a function, your brain is a function, your knees have a function to do. So let's create a first function. So basically the syntax is just create def. So we'll call the function test strategy, and I'll pass on some variables into it. So it can be stock, the name of the stock, the start date, the end date. You can change the name as much as you like, the SMA. We'll just get a colon here, and then when you press enter, you're basically gone inside trading that function. So let's test this function. Let's write down the duties of this function. So first we need to download whatever data we have. So I'm going to do df equals, the library, the Yfinance library. So we do the Yfinance library, and we're going to call, it's not Yfinance, it's actually yf.download. We need a stock name, so we pass on that stock because the stock name is written here. So we pass on the stock. We call the start equals start, and end equals end. So basically whatever the start date we feed into the start and end date we feed into, that gets stored into that start. So then the df can download the data from the yf library. And then we need to just get the data of the close. So I'm going to write another variable data, and I'm going to write df.close and then 2_frame. So we can convert that close to a data frame. And then we need to calculate the returns. So data of returns, daily returns equals, we've done this before, np.log data.close divided by data.close.shift bracket 1. So that's the data of return. So now we got a new column for data of returns, and then we're going to do the data SMAS and SMA long. So SMAS equals data.close.rolling So the first one is the SMA. So let's say we're doing a 50 to 100. So we need to pass the first 50 to 100 into it. So I'm going to call that int so that it's here converted. So int is like an integer, float is like decimal points, string is like alphabet. So because 50 is like a number, we need to pass the integer into it. So SMA 0. So I'll tell you why we are doing this in a later stage. But as of now, just walk through this. Dot mean. So basically the first moving average is calculated for the SMA short. Similarly, we do it for the SMA long as well. So I'm just going to copy and paste this. SMA L. So instead here it'll be SMA 1 dot mean. Again, I'll let you know how this works a bit later. So again, we need to do the drop NA function. So drop NA in place equals true, and then we need to calculate the position. So data of position equals np dot where data of SMA underscore s is greater than data of SMA underscore L, then return 1, else go short, which is -1. So there you go for that one. So now we need to find the strategy return. So data of strategy equals data of returns multiplied by data dot position dot shift 1, the same philosophy that we did before. So you can just fast forward it if you want to, but it's better to go through it line by line so you understand what's going on. Again, we need to drop in any cases of NA that happens. So in place equals true, and then we calculate the return. So return as in we'll do the absolute performance. So if $1 is invested, what happens? So it basically is np.exp data of strategy dot sum, and then we've got the standard deviation as well, so we'll return the standard deviation as well. So basically again it is data of strategy oh my god strategy dot std function asterisk np dot sqrt 252 data of strategy dot std asterisk np dot. So now we need to return these two values, the RET and STD. So return RET comma STD. So that's it. That's all we need to do for the function. So I'm going to run this function. Then I'm going to use this function to test the strategy. So the best way to do is we need to name the strategy here. So test strategy. So which stock do you want to do first? So let's do Microsoft. So MSFT. So the stock name is Microsoft. Let's do the starting date to be 200101 and the ending date to be 2020-0101. And here is the thing that I was talking about. So 50, 200. So what basically happens here is you see this SMA 0 and SMA 1, that's like arrays. So when SMA 0 is mentioned, it takes in 50, and when SMA 1 is mentioned, it takes 200. So SMA S calculates a 50-day moving average, and SMA L calculates the 200-day moving average. So I'm going to run this. Hopefully we don't have any errors. Let's see what happens. So let's download the data. Okay, we do have an error. So let's see where the error is. So key error SMA L. So I think we mentioned a small letter L here. So we'll run that again, run this, run that again. So there you go. So we basically got a very poor returns in the Microsoft with this 50 crossover 200-day moving average. $1 became 0.41, which is not really that great. And the standard deviation is $29. So let's try this with Apple instead. So AAPL. So this was pretty good in Apple. So Apple actually converted $1 to $16 with a 36% standard deviation, which is not that bad. So how about Tesla, say for instance? So Tesla wasn't there from 2000. I don't think so. But anyways, we'll run this. So that $1 became $1.39. So it's like a 39% increase. And with 49% standard deviation, that's not really good. That's a massive standard deviation. How about for SPY index? So let's see that. So SPY $1 became 4, which is really nice, and then the standard deviation is only 8, which is expected because SPY is like the largest 500 stocks. So this is basically what creating a function is. So remember, we did it line by line for every single stock. So you can actually just use this function and save it, and then just backtest it over multiple stocks and find out which is the ideal one. So you can also play around with this 50 to 100 as well. So I'm just going to walk you through again how the strategy works. So when strategy as in this function works, so when you pass this, SPY gets stored into stock, this 2000 January gets stored into start, the 2020 gets stored into end, and SMA gets stored, 50 to 100 gets stored to SMA. And then we're using these values to download the data, to calculate the returns, to calculate the SMAS and SMAL, and basically calculate the strategy returns. And then we are returning the annual return, the $1 return and the standard deviation. You can actually calculate the drawdowns and also the annual return as well. We know the calculation, we have discussed it before. You just have to plug it here and then run it. So this is just a very beautiful first function. You can create all kinds of changes to it. Like remember, like I said, you can make changes to this. Instead of going long, you can go short instead, and or you can just take a long bias, like we discussed before, or basically a short bias as well. And you can backtest multiple strategies or multiple stocks just with one line of code. And that's the beauty of coding. You can do multiple things in one go. So hopefully you guys understood our first function. Then we'll now discuss about classes as well. So let's create our first class, since we have already discussed our first function. So we'll actually create our first class. So I'm just going to write it down. So hashtag creating our first class. Now the reason why we're going to create a class is that we can use these functions in maybe some other Python files. You don't have to go through the whole process of writing down this strategy all the time. Of course, you can always copy paste it, but it's much more useful if you have got like a class and a Python file stored somewhere. So whenever you want to backtest, you can just bring that up. So let's create our first class. So the syntax is pretty simple. So it's class, and let's call it SMA backtester. And basically we've got the function parentheses, and then we have the colon, and then there we go. So I'm going to go explain some of the things that we use. It's more, I don't want to define it to you and make it sound complicated. If you want the pure definition, you can always search it online, but I just want you to understand from an example perspective what we're discussing. So you can apply this when you code, rather than learn from a definition perspective that you learn in schools normally. So let's create a first function. So it's def init. So this is the only complicated function that you need to know about in the class, but I'll explain to you how it goes. So remember, in the function we pass different variables, so SPY, the dates, and the SMA. So we're going to do the exact same thing in the init function. So self is like a standard, that's like a default, and then obviously the symbol name, and we're going to do the SMA underscore short, and then SMA underscore long, and then start date, and then end date. Then obviously when we declare a function, we need to have the colon, and then here comes use of self. So what happens is basically self.symbol. So I store the symbol into self.symbol. Similarly, I store the self.smas is used to store SMA underscore s, self underscore SMA underscore L. Sorry, it's not underscore, it's here dot. It's a mistake here. Apologies for that. Will be equal to SMA underscore long. Similarly, self dot start equals start, self dot end equals end, and initially the results is nothing, so we're going to call self.results equals none, and then self.getData. So basically we're creating a function to get the data. So, and we need to automatically start this whole thing. So what happens here is essentially we use these, for these functions here, like the data returns and data.close and then the starting date and the ending date and the SMA0. So here, instead of using SMA0 or SMA1, we basically use the self.smas or self.sma1. Similarly, instead of using the symbol name here, we actually use, like stock here, we actually use self.symbol. So that's all you have to do here. And the self.getData is a function that we'll declare, which gets automatically initialized when we call the SMA backtester class. So first, let's create the data, the function for getData. So get_data. So what I'm going to do is I'm going to copy all the thing that we hear, the first small paragraph, because that's where we actually download the codes. So I'm going to copy this. I'm going to paste that. I'm going to make some minor changes, which you will see in due course. So the first change you need to do is you need to make sure it's all in line. So again, df is equal yf.download stock. So instead of stock, what do? We do self.simple. Self.simple. And instead of start, what do? Self.start. And instead of end, what do? Self.end. So the reason is I can use this in many of the functions which is there in a class. So class is like lots of functions in one thing, so we don't have to do all these functions separately. So now we've got all the things necessary for downloading the data, but here we need to make a few changes. So here it's going to be self.sma underscore yes and self.sma underscore l dot mean. So yeah, and let's also store this data somewhere. So I'm going to call it self.data2. I don't know if I might use it later in the future, so I'm going to call it data, and I'm going to return the data as well. So now the data gets returned from the getData function. Now we can use the data anywhere else we want. So let's create another function for test results. So test underscore results, and I'm going to call it self. Meanwhile, there's a self here as well, which is also part of the syntax. And then again here, we're just going to copy paste what we did here, but with the minor changes as well. So I'm going to copy this one here. Return standard deviation. I'm going to copy paste that there. Let's make sure everything is in line. Okay. So remember we stored the data to self.data2, so now we can actually use that. So we can actually call data equals self.data2 dot copy. So we're going to copy whatever the values in it, and then obviously we're going to drop any NA problems there as well. So again here, what are the other things we need to do? Data of returns, data optimization, shift form, that seems okay. But let's add something exciting as well. Let's add the comparison of a buy and hold with respect to the our strategy. So let's create a new column. We'll call it returns BH, which is the buy and hold. Returns BH equals data of returns dot cumsum dot apply bracket here cumsum dot apply np.exp, and obviously the data of the strategy, let's call it strategy results, data of strategy dot cumsum dot apply np.exp. So it's data of strategy results and returns buy and hold. we call it return strategy. Return strategy. Okay. So let's also calculate the performance and the outperformance as well. So that will be much more better than just the return standard deviation. Obviously, you can actually return anything that you want, but I just want to give another example. So I'll just leave that here. So let's see the performance. So performance is basically performance equals data of the return strategy. So it's basically this one. Dot ilog of -1. So ilog of -1 is the last row. So basically you get the final value of that, and then outperformance equals basically performance minus, we need to find the performance of the buy hold as well. So data of this one here, that's returns buy and hold, which is the last digit, dot ilog -1. So basically it just subtracts the final value of the buy and hold and the final value of the strategy and subtracts that, and what we get is basically the performance. So again, let's store the self.results, the data to self.results, so we might use it somewhere else. So what I'm going to do is, rather than returning this annual return of standard deviation, I'll rather return this time the performance. So I can return the performance and also the outperformance. Now obviously the number will be so big, so I can actually round that number. So you can do round performance, comma 6, and outperformance, again I can round this, outperform, comma 6. So that's the function for test results. So let's also create another function to plot the results. So I'm going to do plot underscore results. That'll be self. So first let's talk about a thing that we didn't do the entire of this video, and that's essentially an if or else statement. I'm pretty sure we did an np.where statement, but we haven't done like an if or else statement. It's basically pretty simple. The np.where was right here. So if an else is basically if certain conditions are met, do that, and else do something else. So in this situation, I'm just going to add an if condition so that you guys understand the if else statement, but also it'll be beneficial for you in this function. So if, say for instance, we haven't got any data or we haven't got any results yet, there's no point in plotting the graph. So when somebody does use the plot results function, we don't want it to plot anything, so we have to give them a notification saying, hey dude, listen, you haven't run the strategy function yet. So if self.results, which is the self.results here, equals none, so if is none, then print run the test please, and else. So you go back and then you put again an else, and then you put a colon there as well. You give, let's say, I'll give it title here. So title will be, we'll do that, you know, the braces bracket that we decided before. SMA underscore yes. So this is a title for the graph, equals this one, and we'll give another line, and then SMA underscore L, another brackets, and then obviously we need to fill out this parenthesis area. So what I'll do is we'll just give another bracket here, line here as well. So dot format. So we need the first SMA short, that's self.simple. So the first one will be self.simple here, and then self.SMA short, and then self.SMA long. So basically format, and then self.symbol, that will be the first brackets, and then self.SMA underscore s, comma, self.SMA underscore L. So that's sorted, and now let's plot the graph. So that'll be self.results, which is a results table, and then we'll give 2 brackets, and that will be the returns buy and hold, because I want to plot both the returns buy and hold and also the returns of the strategy as well. So return strategy as well, copy, and then we need to put quotes in it, which I'll do in a bit. So it's quotes there, and then quotes here, and then obviously the plot function. So plot bracket title equals title, which is the title here, and fig size equals 12,8, which you've done multiple times before. 12,8, another bracket as well. So yeah, so I think we should be ready to go. Hopefully we don't have any errors, but then we'll see how it goes. So let's run this. Okay, unmatched and line 16. Where is line 16? Data to close rolling. Okay, SMAL. Oh yeah, there's additional brackets here. So let's run this class. So tester equals SMA. We'll just copy paste it, so it'll be much more easier. We don't have to go through the whole process. SMA backtester, and then we'll just give it a symbol. I think I'll give SPY, and obviously what other format that gave? We gave the SMAS, SMAL. Self is not included. So symbol SMAS, SMAL, start and end. So I'm going to give it 50, 100, and the start I'll give as 2000, 0101, and then 2020, 0101. So hopefully we don't have any errors. So let's see what happens. Okay, so we have downloaded the data, and I assume this def.getData function has been worked out. That's why we see this 100% one-upon completed, because normally we see that when the YF download takes place. So now let's see the test results. So in order to call the test results, what we need is we need to do tester is this one here, dot test results. So I'm just going to copy that. Test results, let's say yes as well. And then let's see, hopefully we don't have any errors. Okay, we do have an error. Date 2, so, oh yeah, it's data 2. Okay, so here we go again, round 2. We downloaded it. Okay, so here we go. We've got 2.6349. That's the performance, and the outperformance is by 0.3. So let's plot the graph as well. So again, tester dot plot results. Copy that. I'm going to paste that there. And then I'm going to run. Again, we've got an error. Title reference before assignment. So that's here. Where did I go wrong? Title equals title. Oh yeah, so here it's equal to, not colon. Again, we have to run the whole class again. So it's downloaded that. Tester results. Tester plot results. So there you go. So returns of the strategy is there, which is in the orange graph, and then returns of the blue is the buy and hold of the SPY since 2000 to 2020. So in this strategy, the SMA 50 and SMA crossing SMA 50 100, that seems to work very well in the SPY, but maybe some other stock it won't be working that well. So now you've got an idea on how the class works. I've created a class, and then I've created a tester to store the class there, and then I've used the functions in that class to run and compare. So since we've created this whole function and this class, you can actually use it in future for your reference rather than writing the code all the time. So one of the things I'll do here is I'll give you a sample on how that goes. So I'll create a new notebook. So I'll give a new Python one, and I'll call that class SMA Python notebook. And then I'm going to copy this entire class, and I am going to place it here, and I'm going to save it. So once you save it, you download as a Python file, .py. So this one is normally a pynb file. So we need to save it as .py. So we click on .py and we'll get a file here. So SMA Python Notebook. So I'm going to rename this one as SMA Backtester. So SMA, I'm going to put a small letter, SMA Backtest. So SMA Backtest.py. So I've saved it. So now I have to copy this and paste it in the same place where my Jupyter Notebook is. So in this place, it's basically in Untitled folder 2. So I'm going to paste it here. So then I can use it. So SMA Backtest.py is there. So now if I go to Untitled folder 2 and click on SMA Backtest.py, you basically see the whole of SMA Backtester file that's here. So regardless, we will need many of the libraries as well, like the import Yfinance and pandas and numpy. So I'm going to copy that and also paste it here. And then I'm just going to save it. So we've actually created a Python file, SMA Backtest. So imagine you are creating a new file or a new notebook, and you feel like in this place you need to create a strategy, and you want to backtest a strategy, and you want to backtest an SMA backtest. So rather than coding it all over again, you can actually, just with a few lines of code, do it yourself. So I'm going to call it SMA check, SMA class check. And what you do is, you know the file name of this, that's SMA backtest.py. So what I'm going to do, from SMA backtest, import the class SMA backtester. So I'm going to run that. So yeah, so we have now imported the SMA backtester class here. So now I can run the exact same thing that I ran at the bottom of this thing here. So here, so I can do this thing here, tester equals SMA backtester. Hopefully it will work. Awesome, so it has downloaded that file. Let's see what we get for the test results. You can see the performance and the outperformance. You can always put in the standard deviation and the drawdowns and annual returns and all those other things, but this is just an example for you guys to understand. You can also do the plot results as well. So there you go. So we've got the returns of strategy and the returns of buy and hold. So this is the beauty about storing it in a Py file, of having a class and storing it in a Py file. You can use it whenever you want, wherever you want. You don't have to go through the codes all over again. Obviously, you can always copy paste it, but this is more of a professional coding way of doing things. So let's try out another, maybe like Apple. Let's see whether it did beat the market. Test results. So this one, not really. It didn't beat the market, I guess. So let's see. So the return of the strategy was extremely poor. The buy and hold strategy obviously beat the 50 crossover of 100 strategies. How about I do 1 and 200? Tested our results, tested our plot results. So there you go. Here the tester strategy has performed much better than the buy and hold strategy. So you can actually try out different combinations and permutations. But remember, this is something which has both the long and the short side. So remember, we discussed about just having a long bias in stocks. So that's a really good idea as well. So I think we have reached the peak of our coding side of things. Now we'll discuss more about APIs and things like that. This is the crux of most of the things. I think we've dealt with many other things as well. So we'll actually give you another challenge as well. So this challenge is hashtag. So watch our YouTube channel. Our YouTube channel, there's a video called Stan Weinstein's Trading Strategy. So watch Stan Weinstein strategy in YouTube, in our YouTube channel, Quant Program YouTube channel. You'll see a strategy by Stan Weinstein, which I've coded and backtested. So I've done this here in TradingView. The code is also freely available in the description. So what I want you to do is I want you to backtest it here on Python. So whatever you've learned, you've got the tools necessary. I've taught you all the tools necessary. You see what the rules are in that video here. For a standard procedure, you can actually check out our download it from our TradingView codes if you want to. Otherwise, you can code it right here and then backtest and see what you get, see what the results are for different stocks. This strategy has worked tremendously well since the day I put it in. So I think I put in April 14. There have been lots of great comments, lots of great feedback of people saying the strategy worked very well across the financial markets this year. So take a look at it, and I want you to code that, and I want you to backtest this, create a class, save that class somewhere in a Python file. So I'm going to write it here. So yeah, so once you get that, you'll get a flow of, okay, because there are lots of things we deal with in the Stan Weinstein strategy. So not only are we dealing with close, we're also dealing with weekly data. So here we're done with daily data. I've showed you how to download weekly data, and also we deal with the moving averages, which I've dealt here already. We also deal there with volume, so that's a really good addition. We know we can already get the volume from the Yfinance data, so you can actually use that as well. So then you can create the strategy. This one, Stan Weinstein strategy, is a long bias strategy, so it'll be really interesting how the results are. You would be shocked with how amazing some of the results are. But regardless, I hope you guys got an idea on how to code in Python and backtest in Python. So let's now discuss about APIs. So I don't like the whole definition approach towards learning anything. I think that's one of the biggest problems with regards to learning anything. Even in schooling, most of the time we focus on learning as compared to a practical experience. We tend to understand the definition. So all through this video, the way I've taught is basically through the process of practical examples. So we'll do the same thing with APIs as well. So the definition of API is essentially application programming interface. You can get the details completely online on the actual definition, but theoretically, from a practical example, it's like talking between two people. So it's like you asking your friend for an apple and then the friend giving you the apple. Or you going to a bar or a restaurant and looking at the menu and ordering a pint of beer, and then the waitress or the bartender giving you back a pint of beer. So that's basically what an API does. It's like talking and exchange of data and communication. So there are many APIs. Depending on a broker, APIs can change, like their process or their functions can change. So there is APIs for FXCM. There's also APIs for interactive brokers. So depending on your broker, if you can go to their platform and then find out the details of their API, then you can actually do it yourself. But regardless, it's easy to go through it by just making a few statements. I'll run through an example as well. So I'll give you an example of AlphaVantage, and I'll go through that process so you guys get an idea on how this API process works. So AlphaVantage is, just Google AlphaVantage, and if you can go to, they give you data for practically all the stocks and the cryptocurrencies and the technical indicators and everything, and you can actually download it. You can download the API key. So what you do is you go to the AlphaVantage website and then you get your free API code. So you just enter the details and they'll give you the API key. So once you get the API key, what you need to do is you need to install the API in your Anaconda. So similar to the way we did for the Yfinance, we can actually do it in the Anaconda navigator. So just go to base root there and open terminal and just write in pip install alpha_vantage and just click enter, And there you go. So now Alpha Vantage is now installed in the Anaconda navigator and in your system. So you just go to the your Python file, create a new Python file, and then similar to what we did in importing the class, we need to import the Alpha Vantage time series as well. So for that, we just do from alpha underscore vantage dot time series import time capital series, and just click shift and enter. Just wait for that star to go away. So meanwhile, when the star goes away, I'm going to put in my API key. So I've got the API key, so similar to yourself, you guys will also get an API key. So I'm going to fill in my API key, which is H456ZLCOCHH7CH10. So I'm going to delete off this API, but you guys have to create and put your own API in that system. And once you enter that, shift and enter. So now the API key is stored in that API key. So now I need to store it using the time series thingy here, just as we called that class before. So again, it'll be time series. And then key equals API key, which we just did. So I'm just going to copy paste that. And then output format. So you can actually get in different formats. So I want to do it in pandas formats. We've been discussing pandas considerably here. So we'll just do pandas format. So output underscore format equals pandas. So if I just click here and do shift and tab, basically you'll get all the details of the default values and also what kind of things to be put in. The indexing type is date and things like that. So by default, indexing type is date, so you can actually change that and all those other things. So anyway, we'll just do the basic stuff, and then I'm gonna do shift and tab, and then comes the downloading of the data. So if you can go to the maybe in the support section, you could actually see what kind of data we can get. We can get intraday data, daily adjusted data, and you could also see what kind of functions to use and all the other details. But I'm just going to go some basic downloading of daily data. So I'm going to call data equals TS, which is a TS right here. TS, let's scroll back at there. So TS dot get underscore daily. And we'll just write, let's download Apple. Let's see whether we get the data. Okay, and let's see whether we have the data. So there you go, we've got the data entirely in the volume, the close, and the highs and the lows. And then let's see just the pandas one. So I'm going to just do data of 0, so we basically get in pandas format. So there you go. We've got a data frame format, and then I'm just going to do is I'm going to store this into a different variable, so then we can actually work with it. So there you go. So now I can find out what are the columns available. I mean, the same processes are pretty much the same. Data2.columns, and then if you want to just choose the close value, you can just do data2 to bracket, and then make sure you just don't write close, because the columns is this is the column. So then you just copy and then you just paste there. So basically you've got the data2.close, and you can actually convert that to a data frame and all those things that you have done before. So 2 underscore frame. So there you go. So these are some of the things that you could do, and then once you get that, then you can basically send the strategy. So in Alpha Vantage, it's just basically for downloading. So similarly, when you do it for FXEM or interactive brokers and things like that, just like you have the get daily, you'll have another function to pass on the trade. So you can download the data, you can backtest the data, and then you can also send the information to buy if certain conditions are met. So if you can see here, most of the data is from 2021 to 2022. The data is quite small, but if you want more and more data, you need to have paid API services. So there's another company called Polygon .ai. I think it's called Polygon .ai. Polygon.io, sorry. So it's called Polygon.io. And you can basically get all kinds of quality data. I mean, it's used by many of the big companies out there. They also got stock API and crypto API. You also get tick by tick data, get by tickers, and then level 2 data and things like that. So again, most of these functions can change depending upon which broker you use. But I hope you guys got an idea on how APIs generally work. But it's really important that you invest lots of time in getting quality data, because quality data comes with a price. So another platform I generally use is Data, which I use for backtesting, but it's quite expensive, but it gives you the best data out there. So in my course, for the quant program course, for the portfolio backtesting and everything, what I did was use the Data. So I use that for Army Broker, but again, it comes with expensive price. But then if you want to backtest proper, you need to get expensive data. But if you just want basic stuff, you just download Yfinance. So anyways, regardless of where you get the data, once you get the API, basic idea is just this: you use the functions to send the information and also receive the information. So I guess that kind of concludes our entirety of the course. You can download all the things from my description. If you want to check out our quant program trading course, that's always in the website. And feel free to ask any questions through our email at quantprogram@gmail.com or at the comment section, and I'll try to respond as quickly as possible. Hope you liked it. Have a great day.